Assalamualaikum. Hi guys. In this video, I'm going to focus about the third variation in atomic radius down the group. So as I mentioned before, there will be a specific layout for explaining the atomic radius for elements down the group. You have to know that the factor that we will use when going down the group is screening effect. Screening effect depends on principal quantum number, or we call it as n. So when n value increases, screening effect will increase. Hence, the distance between valence electrons and nucleus are larger. That is why forces of attraction between nucleus and valence electron becomes weaker. Thus, the atomic size of element going down the group increase. So I'm going to put a big note here. Please make sure you understood screening effect or shielding effect is where electrons in the inner shell shield the electrons in outer shell from nucleus. So in this variation, I'm going to introduce to you one acronym where we are going to use this one for our layout, NSAS. N is referring to the principal quantum number. When n increases, S here is screening effect, increases. A here is attraction between nucleus and valence electron. It will decrease. Hence, the atomic size here for S will increase. So, daya tarikan antara valence electron and nucleus is very important. Sekiranya daya tarikan is very weak, the size will become larger. Let's go a bit more how to describe this part. When going down the group, you already understand that atomic radius of elements becomes larger. For example, I have lithium, sodium, potassium and rubidium. You can see that all of them got different period based on their highest n value. And you can see that the number of inner shell for sodium is 1 based on n equals to 1. The number of inner shell for Na is 2 based on n equals to 1 and n equals to 2. The inner shell for potassium, you got 3 of them based on n equals to 1, n equals to 2 and n equals to 3. And same goes for rubidium. The n value or the number of inner shell keeps increasing. So what can you see that when your number of inner shell increases, there will be increasing number of inner electrons. That is why for element with most inner shell electrons will experience largest screening effect compared to the element with less number of inner shell electrons. Because you can see that lithium and rubidium will experience highest shielding effect compared to lithium. Because rubidium, dia ada ramai sangat yang akan block elektron dalam inner shell ini untuk block satu elektron daripada valence electron. Compared to lithium, dia hanya ada 2 elektron sahaja untuk block satu elektron daripada 2s. So that is why it is very important for you to know and to determine the number of inner shell electrons. So you can see that from this variation, based on the graph, it shows that down the group, the size of atom increases. So I hope by this moment, you can know how to differentiate 3 variations for atomic radius when across the period, going down the group, and a special case across the first row of transition elements. I hope you know how to use which layout. So that's it for this video. I hope you are clear as well how to explain or to describe the shielding effect. Till next time, I will see you in the next video. Bye!